Now, our tour begins in the centrifugal UPS room because that was just fascinating to me that there's a spinning UPS instead of batteries, but that room is actually the loudest room we record in throughout this entire video. The audio is still good, you can still understand it, and the first question that wasn't on camera that I asked is, how long does it take to switch from a total loss of municipal power to these UPSs running before the generators start? And well, that's where we're going to start our tour.
But you said 16 seconds?
So 16 seconds is the amount of time it takes for one of the generators to go from off to 60 miles an hour in a sense. So think of a semi-rig doing a quarter-mile strip time. It's doing it in about 16 seconds.
Wow.
So that's what's needed to be able to get the facility from not having power fed by the utility to being able to be self-sufficient on its own. It can range from anywhere from about 250 kilowatts up to about 1.3 megawatts in size.
Okay.
And what happens is there's a large rotating drum inside there that's spinning, magnetically levitated so that it is able to have very little friction in a hermetically sealed container. And what happens is when the power goes out, the resistance of the motor windings slow that container down as it's generating power, and it slowly spins down. When the generators kick on and everything's hunky-dory, those same motor windings are now a motor and will spin it back up and get it going.
How much maintenance has to be? They're pretty maintenance-free, I'm assuming.
They're pretty maintenance-free, but there is still a fairly rigorous schedule to it.
Yeah.
The floor here had to be laser leveled to make sure everything was nice and flat. And then these things have to be calibrated, maintained, and then if there's an issue, your on-site team needs to be certified to be able to do the maintenance on there. Again, hermetically sealed is a little bit of a challenge to do on-site, but that's why you have redundant numbers of these in a data center.
So what we're looking at is the diesel generator backbone to a data center. So power goes out, this is ultimately what kicks on to be able to provide power for the building. They range in size from anywhere from about 500 kilowatts up to about 2.5, 3 megawatts apiece. In this case, this unit has 4 turbos on it, allowing it to generate a massive amount of horsepower. But what's really cool about it is the level of redundancy that's built into this. You have dual starter motors, so that if the starter motor has an issue, there's a secondary one ready to go. You have fuel filtration systems next to the generators ready to go. You'll notice a raised barrier to be able to deal with fuel containment in case there is an issue. Yep. And then usually you would end up having what we call a day tank, which is a small fuel storage on-site ready to go next to the generators that's able to be able to provide that fuel immediately if they were to kick on. In this situation, you have the cold air will come in from this side of the building, goes through, gets sucked through the radiator, and then out the louvers on the back side. That will all automatically open up at the point that these things are requested to turn on. And again, these things go from sitting still, not on, to full 60 mile an hour, ear bleeding rush in about 16 seconds.
Like if these come on, run that way.
Yes, exit the room. You'll see there are headphones for covering the ear protection by the door there, but all automatic with
like a giant
regular
muffler,
testing.
essentially.
Exactly.
That is really cool. And then you have, like, you got the dual filter system here. We have, it's just cool seeing these. Being in Chicago, I did that U-boat tour, and it's got those giant diesel engines.
Yes,
you know?
very similar sort of concept. You've got redundant, filters for the radiator system, oil system. Everything is designed to be easy to service and redundant so that no single component can take this unit offline. And that is just an absolute massive improvement to be able to have when you're working on a setup like this.
Yeah, and you have it's kind of, I see all the isolation to keep this from vibrating, because vibration is the enemy of data centers.
You got it, 100%. So full suspension tray on these things that are load rated, and everything has a little bit of a flex coupling so that it can shift a little bit and vibrate without causing any problems.
Yeah, it's like even where it connects to the exhaust, where everything, so because these things do have some movement when they start. They're just so massive.
Exactly. And what you have here is the diesel engine, so this is very recognizable, but this back half is the component that is the actual electromagnet generator. So it engages the clutch system, this turns a whole bunch of windings inside, and then this kicks out. Usually, typically 480 to 600 volts, some will go higher than that, into a power distribution system. And then there's going to be a regulator system on here that helps to maintain the RPMs so that the waveform of the power is nice and consistent.
Yes, because you do not connect a generator at off sync.
Correct. Yeah. You want to in sync, and you want the waveform to be 60 hertz because that's what the power is in the US. Yeah. So your generator needs to match that. And if the generator revs down a little bit, your Hertz cycle is going to compress or expand depending on that.
Yeah, that keeping everything in sync is one of those things you don't think about when you're just doing a switch at home or something small, but as you scale, it's like two waves crashing of high voltage is going to shutter these things in a way that's actually very scary.
Very much so. So in a server, when you deal with redundant power supplies, what they're doing is bringing in two power supplies that convert AC to DC, and then they connect the DC bus. DC is a lot easier to do that with, it's easier to balance. But when you're dealing with AC, it's a lot more of a precise dance that you have to do, and a lot more equipment involved to make sure it's done right the first time.
Yeah, that phasing is just so, it's overlooked sometimes by people who are maybe not be familiar with it, but there's a few books on it regarding this where they talk about how they have attacked facilities and just the way they put them out of phase was enough to damage them.
Definitely. When you're dealing with a building block of this size, so some facilities range anywhere from a couple megawatts up to dozens of megawatts. And when you're dealing with power grids of that size, one generator isn't big enough to be able to handle what you need. So you have busing or paralleling equipment that's done. And if that first generator attaches to a bus or a paralleling piece of equipment and has a bad waveform for the sine wave, then it can possibly set the standard. And so when the second generator latches on and says, hey, I can't match that standard, it's going to say, nope, not going to latch on, I'm going to fail, and you'll end up only having one of maybe your 7 generators attached. Can't run an entire data center with 1/7 the critical power generation.
Yeah, and one thing I'll note, it does not smell like diesel in here. It doesn't stink, there's no...
you could eat off these things.
Yeah, everything in here is, it may be hard to tell, but it's really clean for being a diesel room that's got louvers that pull air in and everything else. It's actually something I'm just kind of noticing, especially after doing that little U-boat tour, which you smell, as what someone would say, burnt crayons everywhere. Because if you've been around just industrial diesel equipment and being in Detroit, I go to a lot of manufacturing facilities, so also cool to see these say Detroit Diesel on them. So.
They've been fantastic. These ones have been in operation for a number of years, no trouble, and they're just still kicking, doing great.
Very cool.
This area is the pump room for phase 1. And what you see is the redundant pumps for cooling from this side of the chiller plant to the cooling loops inside each of the rooms. So the coolant goes through, pumps out, routes through, it goes up and then actually goes down, routes underneath, goes into every single room. So most of the rooms have their own independent chain to keep that kind of diversity going and keep it independent. But it has to run coolant all the way through the perimeter of the room because each of the computer room air handlers, they don't have compressors on them. So they're only just big radiators that are taking that hot air, pulling it through the radiator, cooling it down with the coolant, and then they push that coolant right back this way. So these pumps are pushing all the way to almost that back half of the building and back. And what they do is cold water goes in, hot water comes out, and that hot water comes over to the centrifugal chillers here, which then exchanges that heat and concentrates it to the evaporation system and the cooling towers. So for an idea of scale, your normal residential air conditioning unit for a house is usually anywhere from 3 to 5 tons. Each one of these green units here is 1,050. There's a redundant number of them here so that we can have one take over if we were at full load, but we're not usually at full load, so that makes it so that we maybe have 2 or 3 of them on, depending on how much heat generation is on, and they rotate the load across them to kind of balance the hours. Otherwise, you would wear out half of the units, and the other half would be almost brand new. The coolant side, we have a 1,000,000-gallon water tank over in the corner there, and another 1,000,000 over on that side for the other phase. Those are like cold batteries. So think of it this way. It costs a lot of money during the day to cool things down, right? Power's usually at a peak, but at night, it's a lot cheaper. So what they can do is at night, when the heat generation is still static, but the efficiency is super good, they can cool down 1,000,000 gallons of water, drop it in temperature, and then during the peak times of the day, not use the centrifugal chillers as much, but use the cold water to bring into the system to help kind of cool things down. So they use that water as a heat transfer to warm it up instead of running all the other stuff there. Got it.
So now you're taking this 1,000,000 gallons of water you chilled down and you're slowly heating it up during the most expensive times of the day, allowing you to lower your power consumption.
The thermal efficiency is really interesting because there's there's a lot of thought put into it. It's not just, hey, run until it's cool. It's how do we get the most efficient way to do this?
Totally. This half, fiber coming into the area, fiber cross connects. We have a redundant side over there, diversity, so that if, again, you take a chainsaw in the middle of the rack here, you're not going to take out both paths. So we have equipment, powered equipment on this side to be able to handle things like waves to other facilities. So that's dark fiber where we're lighting it up, and we can slice it up to as many 10 gig connections as we want across that fiber. And I say 10 gig, but really there's 40 and 100 gig variants of slices too, and we do that all across the board. We've actually recently had a request for terabit per second requests going across. So we're at those sort of scales where people are requesting that sort of connectivity.
Terabit, nice.
Terabit per second, yep. So distribution to customer cabinets. So this is stuff where each of these panels contains 144 fiber strands. You need 2 strands for communication. So we can handle a really nice plethora of customers, and we've slowly been filling them up and adding on additional ones as customers' needs have changed.
And this backhaul you can facilitate all the way back to like on-prem sites. So you can light up dark fiber from an office building within
100%.
the area and be like, hey, here's where my data, my servers aren't in the server room, they're in your data center.
Exactly, and yet it's coming across locally as if you were sitting on site with them.
Yeah.
We see that very commonly done with office buildings for large organizations where you might want that between your primary data center, your redundant or DR data center, and your office building. And we can set up those rings, help manage it, and make sure that you're going through diverse carriers too. Because sometimes carriers will go through the same manhole or same conduit, and the backhoe will be able to take both of them out in some scenarios. Copper distribution, so anything from IP KVM, so that's your keyboard, video, mouse over a network connection. Really handy when you need to get into the BIOS of the server and it doesn't have the ability to do it built in. We have those sort of services available. Then over here, we start running into kind of copper. And what's interesting is we dealt a lot with copper originally 14 years ago, and it's shifted a lot to fiber. So you can see as the infrastructure has changed out,
It's just all fiber.
it's fiber. Now we're able to reuse these bundles because we have a little bit of extra slack down there. So when we do equipment upgrades, we're not redoing everything from scratch, but these cables all run to existing panels. So when a technician is doing a new service turn-up, they're only working in a panel where they're connecting what's needed. Never are they working on the live devices.
I think something you mentioned with IP KVM,
Yes,
the fact that people don't realize there is enterprise equipment that does not necessarily have IPMI.
100%.
Yeah, this is a thing that happens.
And when you run into a problem with it, you know, the other option is extend a keyboard and a crash cart to the server and sit in front of it. So these things are really great solutions for us to be able to sit there and say, let's help you out with something.
Yeah.
We actually have our own version of that using a Raspberry Pi, which is the Raspberry Pi IP KVM service.
Yes.
We've deployed a number of them because we can go and put it in their cabinet, connect it, and devote it to them, and then when they're done with it, we retrieve it. So we have that as a service for our customers.
That is really cool.
So our Juniper switch equipment, we're a Juniper shop. We're agnostic when it comes to customer equipment, but for us, our preference is Juniper. This is the 3rd iteration of equipment that's been in these racks here. So we've been able to go from Cisco to Juniper and from one version of one model to another version of a different model, all live while the customers don't see any downtime. And the reason is redundancy. I have my distribution unit 1, my secondary right there. I can upgrade one while everything else is being handled by the other unit. That kind of active-active functionality where I know I can flip over in case I gotta do firmware updates, software updates, or anything else along those. Blue means it's an Ethernet connection. Green means it's like a serial or IP KVM or you know, some sort of non-TCP IP connection. And then when we started building out, we had 4 of these racks devoted, but we built out 1. And then as we grew, we built them out. And what happened is we needed a little bit more density. We suddenly had a room that added another 100 cabinets to this room on the build plan. That was never on the original design. But because we do organic growth, we were able to change our technology to a slightly more dense system that allowed us easier maintenance and management. So instead of punch down on the back, I now have a module that I can crimp, terminate, and click in. Very similar to the Keystone system that you would see in residential wiring. But this will recertify at 10 gig without any problem, day in and day out. I've got connections 15 years old that will recertify the same way they did on day 1.
Modular is the way to go. That's
100%.
the only way to build stuff.
And we have racks that have a higher density than this per use. So you can get 48 connections in a 1U size. A little hard to work on.
So when you're working with an organization that cares this much and is growing things organically this much, so this is what happens when you start to grow. Like, it gets a little crazy.
I can take a picture of the back
you
of this.
You can take a picture of this.
People love this. This is the internet's favorite part of the internet.
Totally. This is 15 years of continual development and growth. So this isn't a day one and done. The very first racks were these ones, then it extended over here for our customers, our equipment on the bottom, customers on the top, and it just kept kind of growing that way. Conduits coming in from the underside there are fiber connections from the entrances to the building, so point of entry or meet me room sort of connections. So we have some connections there, and we have some connections over there. But inside that,
and you're doing it all right. I mean, this is the little things like the
sleeves.
So do you have a picture? Yeah, the sleeves.
Yep. The cold side is cool, but it's the hot side where you see the difference in people's experience, and that's where we really come along to help our customers out. 42-inch raised floor. So this is a load-bearing glass tile that we had acquired to be able to do this very thing. You can see the color coordinating of the power cables for the cabinets, but those large conduits are actually distributing power from the room distribution units to our power panels.
Which is
because
cool.
Who doesn't like interactive technology? I'm heating up a sensor with my hand here, and it's going to open up the louvers there, and you can feel how much static pressure there is. It's opening now.
Oh yeah.
So this is the part that you don't really get a chance to kind of...
You have to experience this.
So that is a 5-ton tile right there. So in theory, that has 5 tons of cooling. Do you know how the term ton came along for cooling?
That I don't know.
It's a fun story, and it's quick. So it used to be related to how much ice you needed to cool a room. So back in the days when that was the way you'd order for your, Midwestern movie theater, I need 3 tons of ice to be put in, and they'd have a fan that would be pushing that air across the ice to cool a room down. So if you needed 3 tons of cooling, that was the amount of ice you'd order to cool a room. Nowadays, we know a ton of cooling to be roughly 11 to 12,000 BTU. I say roughly, it's 12,000 BTU, but when you do calculations in a room, we like a little headroom, so we calculate with 11,000 BTU. So you have roughly about 4 kilowatts to a ton of cooling. So right there, you just experienced 20 kilowatts of cooling.
That is neat.
People don't really understand what it means until they get to experience it a little bit. This is a 40-ton air handler. So what it has is a big radiator coil here, variable speed motors for the fans on the underside, and it's just baffled up to get the hottest of hot air, because the hotter the air you can get into this thing, the more efficient the thermal transfer is to the cooling loop, more heat it offloads, the colder the air can be on the underside there.
And that solved the problem.
That solves the problem. You'll notice redundant power connections on these. They're automatic, but if we had to go to the bypass or the utility maintenance grid, we had the ability to manually switch it. When I said the power grid in this building is a little different than everywhere else. So there's something called a STS, static transfer switch, in the data center. And the purpose of that device is to take power from one input and switch it to the other. There's 2 styles. Older fashioned styles, which is mechanical, where it takes the connection, breaks it, and then makes a new one. You have an interruption, power goes out, servers turn off. Then there's like the SSDs of the market, solid state static transfer switches, which is what these are. They have the ability to switch power faster than your power supply can notice. So right now these units have 2 inputs feeding them, and it can choose, hey, I have a primary input and a secondary. If the primary input has any problem, it switches to the secondary. Because it can do that, I can take power from here, run it to one of my power panels, and you have dual fed capability feeding each panel, and you have 2 power feeds going to your cabinet. So now we have the switching at the room. That's expensive to do because these things cost a lot of money. So traditional data centers will usually put this in the back of house next to the UPS. So they put the static transfer switch on the generator / UPS side and the utility as the inputs. So utility goes dark, it then switches over to the generator turning on, and the UPS rides it as the output until the generator turns on, says I'm good, and it latches on to the generator side. That creates a pathway for the STS to use, and it starts charging the UPS back up. So UPS, static transfer switch, generator,
utility. And that's the common building block.
Wow.
This is what 1.3 megawatts of power distribution looks like. Often or not, you have very large breaker panels that are distributing power. So the power comes into the room, breaks out into a larger than residential size distribution panel, and then those go to each of the STSs, which then go in turn to each of the power distribution units.
1.3 megawatts. That's just
1.3. So that is a small city.
yeah.
And this facility has 36 megawatts of capacity in it.
That's
We have facilities that we're in that have up to 300 megawatts of power too.
that's wild.
It is really, really crazy. When we're dealing with co-location, not everyone needs a full refrigerator-sized cabinet for their servers. So we offer half cabinets and quarter cab compartments, I think they're on the other side there, so that we can kind of right size. Sometimes you just need your redundant equipment or some off-site. So we can help alleviate some of the costs by putting two customers in the same physical space. So again, the quarter cabinet idea. So the idea is that you have a fully isolated, secure panel area where you're able to kind of have your space, but you don't need a massive amount. So you're off-site, you're redundant.
It's worth noting too, these are not your generic, all the same cabinet keys.
Correct. So everyone has different needs, and to help facilitate that, so this is a combination lock. We have a key to be able to get in for our side, for our technicians, but there's a code that the customer has and they can use and they can give out. We can change the code at will for them so that they can kind of rotate as needed. We do offer fingerprint-based and card access-based biometric systems for the cabinet level, as sometimes they actually have a requirement that says, I need a card reader or I need a fingerprint reader, but they don't need a cage to be able to do that.
Right.
Now, the next and final stop on our tour is the parts room. There are several technicians working in there, and it's cool seeing all the work they do on behalf of people that have things in the Colo. So obviously you can put stuff in the Colo and maybe go there yourself, but what if you went there and forgot a cable? Or what if a drive goes bad and you just don't have time to drive out to the Colo? They have spare drives, they have spare cables, they have a lot of them.
The reason why we have white, yellow, blue, purple, and green network cables isn't because we really couldn't make up our mind as to what color we want to standardize on. It's because maybe you have your primary switch and your secondary switch, and you want to make sure visually at a glance when you walk up to your cabinet, every server has both connections.
Yeah, so if you bring your equipment here, you have the spare parts that will match your layout.
Exactly.
That's a big difference.
And if you have your own standard, we can help you maintain it. If you don't have a standard, we can use our best practices to help you with that. We also can carry Cat 5, Cat 6, but DAC cables. When you start getting into the 10 gig, 25 gig, and 40 gig things, maybe you don't have a 5 meter 10 gig DAC. And you came on site to put up your new storage array and, oh, I don't have the cable or the connection to do what I need. Well, this is where we're able to help you out, because for us, it's a lot easier to have it on site and ready to go.
I think it's fun too, because you don't realize until you sent some guy a 2-hour drive, 3-hour drive to the data center, you're like, oh, you forgot the DAC cable.
Well, like you ship something off, like the manufacturer's like, here you go, you just spent $40,000 on this new storage array and it's great. Oh, and they didn't include the cables.
Right.
Or the rack mounting kit. So by having the parts on site here, we're able to help you out. And maybe even save you that 2-hour drive, because we're here 24/7, so why don't we rack it up for you?
Absolutely.
So SSDs, they wear out, they go bad, and they're specific to
the
size.
most common failure now.
And the difference between, oh, that's an 800 gig versus a 960 gig can be the difference between you having a good day and a bad day.
Yeah, very much so.
So for us, we stock all the common sizes of both enterprise grade rotational drives to solid state drives to PCIe memory based systems, so that we can plug it in and help it out. We have to maintain systems ourselves, so we need these spares for our own internal use, but why not be able to make it available to our customers?
But the fact is you have all this too.
Sometimes you have a half-height PCI slot and a full-length card. Yeah. And Lord knows you've had to connect a storage array, and like, which one did you need? The mini SAS or? Hundreds of power distribution units with their variations between manufacturers and feature sets. Sometimes when you're holding a cold spare for someone, you know, what you need has to fit this way, where the outlets are going this way, or maybe you need something that's a little wider. If you have one in production and it fails on you, you have to have a spare. The problem is, well, it depends. Did you have something that ran 208 volts at 30 amps, or were you running something that is, 40 or 50 amps? Is it a twist lock plug that looks like that? And then if you come over to this side, or is it one of these ones? where we start getting into kind of the fun 50 amp level. Heaven forbid you are at the 60 amp level, which gets to something around that size.
Oh, there's the beefy one.
And I think we have one more fun one here. I should have a 60 amp receptacle floating around under here. And this kind of comes down to the spares. Here we go. So if you took the Metra at all,
Yeah.
that is the twist lock system you start running at 60 amps when you're dealing with multiple phase power. Same style connector used on the train systems.
Yeah, neat.
So now the dilemma is, great, all these choices, which one's the right one? Well, that depends. The problem is you have all these different form factors because you have all those different connectors there and different requirements, which means when we have to ship something to a different country that has a different power standard, what do you choose? Well, it's easy to make a mistake here when you have all these options here, and they're all very similar to each other. So what we have over here is a really cool product from Eaton, and they call it the UPDU. So what you have is a PDU that has a connector here, a multi-pin connector that, depending on how the cable's wired up, changes how the PDU works. So this thing can be a 20 amp, 208 volt single phase power distribution unit that can handle about 3 kilowatts of power, or I change the cable out and it can be a monster that can handle 17 kilowatts of power.
Oh man.
All without having to change out the chassis.
Very cool.
And we'll show you a little later on the reason not having to change out the PDU is so important, because these things get buried inside the cabinet.
I like the little green test lights.
Totally. It's just cool. So these are brand new. Now imagine if I had this chassis, I could buy a couple and have them at every data center we have across the world, sitting there waiting. You order a 30 amp circuit, that's 208 power, great. I send out a cable, FedEx envelope, overnight, easy international shipment. You're ready to go. Oh, you had a problem with one of these units in your cabinet? Great. I unplug the cable, pull out the box, put a new box in, done. The most common scenario we run into, though, is, hey, I started buying services from you 5 years ago when my power needs were this. But now I've grown to the point where I need something more. What does it take to upgrade? Well, it's a two-person job of installing additional power circuits under the floor, then removing one of these things physically while it's live, putting a new one in, migrating all the power plugs, and then doing that again. And when you have to do that twice on a live environment, it takes a lot of time and it's highly stressful. Or I just change out the cable and you're done.
That's just simple.
It's truly insane how elegant the solution is for being able to handle both US, North America, South America, and international European, Asia Pacific power needs, all with the same cable.
A big thank you again to Deft for this tour, allowing me access to their data center. This was just a lot of fun. Really enjoyed it. Hope you enjoyed it as well. Leave your thoughts and comments down below. Let me know what you liked or didn't like. Like and subscribe, see more content on this channel. And of course, sign up for my forums, forums.lawrencesystems.com, to discuss this topic or any other topic you've seen on my channel. It's a great way to engage with me. And thanks.